it depends on the question that you have in front of you. So that's how this formula is being explained to anybody. To a lay person who has never done engineering, if you explain that to the person, he's going to understand that much better. So how can we prove that formula? We start by saying that the energy into the system minus the energy out of the system is equal to what? Change of energy for the system. Change of energy for the system. So this is step one. Step one equation, because this is equal to what? The fundamental, or you can say the main equation. The main equation, the main equation for change of energy. This is the main equation for change of energy. After that main equation for change of energy, now we are going to look at this question and ask ourselves, what is the energy into the system? What is the energy into the system? The next question we're going to ask ourselves, what is the energy out of the system? And the next question we're going to ask ourselves, what is the change of energy in the system? And I ask you to look at this question and tell me, the energy into the system, it is seen as form of what? Seen as form of what? As form of heat into the system. So we have what? So we have this is equal to what? This is equal to what? Q. And then this is equal to what? Work done by other system, and then this we can see that based on the question, we can see that the resistance with the cylinder turn on when a current is passing through the system at a given time for a 12 voltage, and there is a heat loss, which is why I put that Q. So we cannot see that because the problem is maintained at a constant pressure. It is maintained at a constant pressure. So the energy for the system now is established from the concept of the kind of problem I have. When you define the kind of problem, you know that I'm dealing with a problem that is actually a constant pressure problem. Then you can define the energy for this kind of system. It therefore means the change of internal energy is equal to 0. It therefore means the change of kinetic energy is equal to 0, and therefore means that the change of potential energy is valid, and it can be written as what? As U2 minus U1, and therefore we can say that we have Q minus W other minus W boundary equal to what? U2 minus U1. So this is the order, and this is mandatory. This is the boundary Banjo work done. And how do I proceed further? I know that this Banjo work done is written as what? Pressure with respect to what? V2 minus V1. That is the Banjo work done when there's a change of volume for any system. And I can write this equation as what? Q minus W, which is the other work done, minus what? P0 into what? V2 minus V1 equal to what? U2 minus U1. And I will say that heat minus other work is equal to what? Is equal to U2 plus P2 V2 minus U1 minus U1 minus U1 minus U1 plus P1 V1. Remember, this is the change of energy. So this is the change of energy. It's the change of energy because we have only potential energy for the problem. We have internal energy and kinetic energy zero because we are talking about a constant pressure situation, and therefore the Banjo work has been established with respect to the normal formula we use, and we can be able to rewrite this expression because we know that enthalpy is equal to what? U plus is actually big U. Remember, small u is internal energy, big U is energy. P and V, pressure and volume. And therefore, I may say Q minus work done, other work done is equal to what? H2 minus H1. And that is the formula we are asked to prove. And this is the change of enthalpy. That's the change of enthalpy. So that is the first part. Let us look at part B.